Okay, welcome to day 2, guys. Now, second day, this is a very big reinforcement day. This is going to be a great day. If you struggled a bit with day 1, this is going to be great practice for us, guys. So I'm really excited to get into day 2. And once again, our topic, we're talking inequalities. We want to work on solving them, so getting the variable by itself. We also want to continue to graph the solution. So whenever we solve them, we want to be able to graph on a number line. Okay, but first let's start with a quick warm-up here. I'm going to give you guys a chance. See if you can write the expression. And again, if you see all real numbers x, that just means x. A number y is just y. But I want to see on these first 6 if you guys can write down the inequality that matches the situation here, kind of the verbal expression. So take a moment, see what you guys can do on these first 6. Okay, so we've got a is greater than 4. Remember, we also could have written this backwards if you'd wanted to. A is greater than 4. These mean the same thing. Yep. C is less than or equal to -2. And again, we like to write the variable on the left because when we go to graph these, we can just follow the arrow for our shading. M is greater than or equal to 1. Again, equal to, so we put the lines underneath. And then F is just less than 2. So F is less than 2. The arrow points to the smaller value. Pointing to F, F is less than 2. These last two here, all real numbers x that are less than or equal to. So less than or equal to 5. And here's an interesting one. For less than a number y. For less than a number y is greater than 10. So here's, see that word is? Is means our sign is coming. So whenever you see the word is, whatever follows, that's going to be our sign here. Greater than 10. Now, for less than a number, that's when we subtract 4. Oh, so we subtract 4 from a number y. Y minus 4 is greater than 10. I know that's a little confusing there, but remember, this is actually our sign there. Let's do some tougher ones. How about number 7? No more than. So no more than 10 people may use the treadmills at any time. Let's use P for number of people. So P will be number of people. And so compared to 10, no more than 10. So we could be equal to 10, but we need to be less than or equal to 10. How about the train for a marathon? A runner decides that she must run at least 12 miles. So R is going to be miles ran. R is miles ran. And how's that going to compare to 12? Well, she must run at least 12 miles. That means 12, so equal to 12, or more. So greater than or equal to 12. And then I'm going to let you guys try number 9, part A and part B. See what you guys can do with those. So let's see how you guys did on these. So I used H to represent a person's height. So H needs to be greater than or equal to 4 feet to ride this ride. Sorry to my short people in class. Nothing wrong with being short unless you want to ride a roller coaster, in which case it is an unforgivable sin. Speaking of unforgivable sins, we know that if a person's speed, we're calling S, and you have the speed limit 35 miles per hour, your speed needs to be at 35 or less than 35. Though, if you drive slower, ... I will run you over. Just kidding, but maybe not. If you drive slower, let's try and make that equals 35 instead of less than once you guys become drivers. Last thing on this page, guys. We want to determine whether we have some possible solutions here. So we want to determine whether each number could be a solution. based off the given inequality. So for example, on number 1, we have 2x plus 4 is less than 20. What happens if they tell us, hey, 2 is what x really is? X is really 2. Plug that in and see if you get a true statement here, guys. So we've got 2 times, instead of x, 2 times 2 plus 4 is less than 20. We got 4 plus 4 is less than 20. We get 8 is less than 20. Is that true? Yes, it is. So we can go over here to A, and I'm going to put a check mark by it. This is a solution. That is a solution. Now let's try for 10. So 10, we plug in, what happens if x were 10? We do 2 times, not x, but 10, plus 4 is less than 20. 2 times 10 is 20. 20 plus 4 is 24. Ooh, yeah, that's not right. 24 is not less than 20. This is not a solution. 10 would not be a solution. So you plug in 2, you get a true statement. 2 is a solution. You plug in 10, you get a statement that is not true. 10 is not a solution. On to the next page. Okay, this page has got the good stuff, guys. If you want to get a good encapsulation as to what we've talked about throughout this chapter, this is the good stuff here on page 6. Now I'm going to do these next 2 problems, 1 and 4, with you guys. And then I'm going to turn you loose on 2, 3, 5, and 6. So let's do 1 and 2 together here. We're trying to graph the inequality they give us. Now they give us that 4 is greater than or equal to b. Now I want to rewrite that. I want to write that with b on the left and 4 on the right. And if we switch the sides around, we also have to switch the symbol around. So b is less than or equal to 4. Now why did I want to do that? Well, if I do that, when I go to graph, I know I'm going to have a point at 4. B is less than or equal to 4. Now, B could be equal to 4. So what am I going to do with this point? I'm going to fill it in because of that right there. And then I can follow the arrow, guys. If B is less than 4, we're going to be shading where all the numbers are smaller. So you follow the arrow to the left. All the numbers to the left are smaller than 4. 3, 2, 1, 0. How about let's do an example of an AND problem. Number 4 here. We've got an AND problem. Negative 4 is less than J. J is less than 4. You notice how J is in the middle? Well, J, just like B, represents our shading. It's all the numbers that meet this criteria. So if I go to graph this, I'm going to have negative 4 here. 4 here. I'll put 0 in the middle. Okay. Now we know we're going to have a point at negative 4 and a point at 4. Now is J equal to either of these? Do you see any equal to lines? Ooh, I don't either. So these are going to be open points. And if J, start on the right side, if J is less than 4, follow the arrow here. We're going left because J is on the left side of 4. And J is less than 4, so we're going left. Ooh, here's the problem. How does J compare to negative 4? J is greater than negative 4. So from negative 4, we head back to the right, and our shading is in the middle. This will always be how an AND problem is. So numbers like 2 and negative 2 and 1 and 0, those are all numbers that J could be. So guys, go ahead and try numbers 2, 3, 5, and 6 for me. Go ahead and give those your best shot. Now, check it out. So m is less than 1. Open circle at 1 because m could not be equal to 1, and we shade left because m is less than 1. Number 3, m is greater than or equal to 5. Could be equal to 5, so we fill in the point at 5, and then we shade to the right where all the numbers are bigger. Number 5, k is greater than or equal to 2, and k is less than or equal to 10. So we go to the right of 2, to the left of 10, both points filled in because k could be equal to both of them. And we're shading in the middle. We got an AND problem. Number 6 is also an AND problem, but I didn't completely finish this problem. Z is greater than negative 3. We see that, so we're going to the right. Z is less than or equal to 4, so we're shading to the left. But if Z is equal to 4, hey, that means we're going to have 1 point that's filled in and 1 point that's open. And that is A-OK. So what I love about this next section is now we get to reverse engineer some things. Now we get to actually look at a graph and write what the inequality would be. So I'm going to go with my favorite letter, C. And what point do you notice we have a point at here on our number line? Looks like negative 2. How does C compare to negative 2? Looks like we're shading to the left where all the numbers are smaller. And is negative 2 filled in? Yes, it is. So C could be equal to negative 2, or it could be less than negative 2. Try number 7, part B for me. And then if you're feeling really creative, you can try part C. So you go ahead and pause the video and try these two. Okay, so we've got D is going to be greater than 1. And then down here I used E. Now this is definitely an AND problem. We see we got shading in the middle. Now remember, with an AND problem, arrows go the same way. Arrows go the same way. And let's start with this. Let's start from the right side and work our way left. So E, how does it compare to 6 over here? We know we got our variable on the left, number on the right. Are we bigger than 6 or smaller than 6? Looks like we're shading to the left, so we're smaller. Could we be equal to 6? Filled in point, yes, we could. Now, we go over here to negative 2. The arrows have to go the same way. We know E is going to be bigger than negative 2. We're going to the right, so E is greater than. And that's a filled in point, so E could also be equal to negative 2 or bigger. So that is a definition of an AND problem there. Now, letter D. Ooh, we got an OR problem. Now, these actually are easier to write, but they can be a little bit tougher to understand. So let's pick a variable here. I'm going to go with, so we got an OR problem. I'm going to go, if you can't read that, I'm sorry. OR. Let's go with P. We got P here and we got P here. So how does P, let's start with negative 6. How does P compare to negative 6? Is it bigger than negative 6 or smaller than negative 6? Looks like it's smaller, doesn't it? Or, so P could also be something else here. So we know P is less than negative 6. Or, how does P compare to negative 2? Looks to me like it's greater than, right? We're shading to the right. So P is less than negative 6 or P is greater than negative 2. It can't be both, right? There's no one number in existence that is both less than negative 6 and bigger than negative 2. No one number does that, but P could be one or it could be the other. So one or the other would be your answer here. All right, and we're going to end today, guys, by getting some practice by solving and graphing. So we'll get to these word problems to start tomorrow. But I want you guys to try and practice right now numbers 1, 2, and 3. So we're going to solve and graph. Go ahead. You can pause the video. All right, let's check this out. Subtract 9. X ends up being less than 3. So we put our open dot, because it's not equal to, at 3, and we shade to the left where the numbers are smaller. We subtract 3 over. We get x is greater than or equal to 4. Now, I'd like to maybe rewrite that. These are the same thing, but I'm going to flip these around, which means I got to flip that sign. So x is greater than or equal to 4. Since it's equal to, we fill in the point and we shade to the right. We can follow the arrow since we rewrote it. Now, number 3, we subtract 3 over. T is greater than negative 4. Now, remember, the bigger a negative number, the smaller its value. So negative 3 is actually bigger than negative 4. So we put that on the right. And if you're going greater than, it's open, circle, and we're shading to the right where the numbers are bigger. If you have any questions, you guys know how to get in contact with me. I'll be talking to you and seeing you soon.